Good afternoon, everyone. I'm Tanmay. If you don't know, we are the ones behind the drone show that happened at Rashtrapati Bhavan during the beating retreat ceremony in 2022. That is the name to fame. But we have been working with the forces since when we started, and it's almost 9 years now. Uh, the vision was simple that we need to build what we need in this country. Now, we realize that as a small startup, you cannot address the challenges that are associated with rare earth elements, with lithium, with silicon. Those things are out of the window. What you can probably do is you can make the electronics that go on the drone itself, make them yourself. It is cheaper and it gives you more control over the hardware that you're going to use. With that philosophy, we started building, and now I'm happy to say that this particular drone is being exported to more than 10 nations, and it has done drone light shows across the world. We want to bring that same know-how and now bring it to electronics that can be used to basically put a drone together. I'm not saying these are hardened, I'm not saying these are mill grade. These are as good as you will get, and the Ukrainians are using something very similar with Ardu Pilot, with off-the-shelf components to great effect. So you need both. You need a mixture of easily available, easily integrable systems. Somebody with minimal knowledge can put a drone together with this and create a large mass of drones. This is level 1. You need this, but then you need something that is slightly better. Now, since morning we have been talking about GNSS denied environments, GPS denial. Now, as a civilian, I grapple with this thing. What does that mean? Does it mean that you have jammed all the channels? Have you jammed L1, L2, L5? You have nothing else there. Would you be better off if I use a dual band or multi-band GPS? Does it make sense for me to harden my GPS? And that is the thing that we have been thinking about, that how do you harden the existing system? Because there is a major vulnerability in the GNSS modules that we have. It comes from a single company. I will not say all of them, but most of them is from U-Blocks. And GPS has a basic vulnerability that you know the working frequency. It's 1575, and you do spot jamming. Your GPS is no longer working. So you don't have a localization solution. Your drone will just not take off. Would you be better off with now supplementing your system with a dual band GPS? That is first. Other is, can you use RTK GPSs? Can you use high precision GPSs? Not as one, but as a system together. We have built something that is a GNSS compass. This is not built for drones, but this is built for basically giving you a heading reference. We got a request that we want to establish a common baseline for our radars and our guns. So for that, you cannot use a compass which is based on anything that is magnetic. This uses 2 GPS receivers, and this is the hardened solution. This is all the IOs are protected against very high discharge. It is enclosed. The power supply is redundant. So this is the kind of system that we want to produce and want to offer as a subsystem for anybody who is making a drone. Other is flight controllers. Most of the flight computers that you see are basically STM microcontrollers, and they are limited in their scope. What can you do if you have a much more powerful processor which can handle not only the real-time processes, reading data from the gyro, issuing commands to the motors, but then can also ingest visual data? Can you do that? That is something that we have been working on. We are trying to integrate more and more powerful ultra-low drift IMUs into our system. And this is where Ardu Pilot and other things fail, because those are built around commercially available solutions. So having said that, then the motor controllers itself, the one that you use are 8-bit motor controllers using trapezoidal control. Their efficiency is what, 85%. Whereas you can get more out of the same motor if you just change the control electronics. We have started building, and we already have 1 kilowatt FOC ESCs that we have put on a wing. And this is the direction that we have chosen to take on making very high, very capable electronics. Last is antennas. Unfortunately, most of what we use is imported. We are now trying to build antennas which have, by design, certain level of rejection of ground-based jamming. Again, CRPAs, controlled radiation pattern antennas, where you have an array of antennas which can be steered away from the jammer. This is something that we have seen the other side using, and we know that this is the very first thing that we should be doing. We have a 2-element system ready, we have a 4-element system in the works. Security of our channels is something that I think we have to address. There are only 2 protocols that most of the drones are using. If we know this, the enemy certainly knows it. And this is a vulnerability that they will use against you. Something that can be easily addressed by just putting a lookup table on your system, which can be changed as per your mission requirement. You don't need to depend on Ardu Pilot. You can make these changes. We need somebody to make these changes and then make it public. You can't have this knowledge with you and keep it with yourself. It doesn't do good to anyone. So if we can come up with a way of centrally saying that this is the protocol that we are going to use, it will be very useful for everyone that is involved. One last thing, as sir has also mentioned, that we have to implement edge computing on our systems. We have stopped using Raspberry Pi and anything that is a single board computer as itself. We have made this mandatory, at least in Botlab, that we will only use processors that is built by the team. So we are no longer using modules. We take an SoC, we build the board around it, and you can make the best model in the world which detects everything, but it's of no use if you cannot deploy it on a UAV. So now we have to basically make models that can run on very low power processors, and one way of doing that is by making clusters of them and putting them on a system. That requires miniaturizing them, and that's something that we are doing. The image that you see on the bottom right is a thermal image taken from the cameras. Something that we have made sure that we are not going to fire these systems at night. So visual odometry is out of the work. It's not happening. You have to do thermal odometry now. That is something that we are working on. Hopefully this will be ready very soon. One last thing is simulators. At some point you'll realize that your production capacity cannot just surpass the trained man that is needed to basically operate that system. And you don't have hardware to basically teach everyone. This is where simulators come in. We use this to test our models, test novel airframes, and this is something that we see as very critical to testing your systems, training your guys in operating them effectively, and training them with certain physical parameters. You can't have perfect radio range. You can't fly something as good as you're flying it at 2 kilometers, maybe 10 kilometers away, or 50 kilometers away. You have to have those physical models which simulate loss, degradation of link, and other environmental factors. So this is an example. This is an example of where normal simulators and your results will match. Nothing is around, no obstacles, it's an open field, and this is where simulation works. It fails in environments like this. This is what we are trying to develop, where your system can emulate RF loss in different environments. With that, I'll conclude my talk. Thank you for your time.